Yes. So, yes, I am Morgan, as 99% of you know. So this is 30 years in 12 minutes. However, that's sort of a lie because I'm not really going to talk very much about the last 5 years where I've been slowly retreating. But I'm talking about this very quickly in 3 parts. As Jerry mentioned, I was absolutely the least accomplished of the 4, but somehow they gave me the leadership of this group, which we called the Realization Group. And later it became the Speech Group, and I'll explain why in a bit. And after a while, amazingly, I became the director. So I'll talk about those 3 things. Yeah. And it's a personal recollection. I don't claim to be covering everything that happened by any means. So the full name was the Realization of Massively Parallel Systems, which colloquially was neural networks. And the thought was to sort of have a vertical integration of hardware, software, and algorithms. I mean, it was sort of ostensibly the hardware group, but really we wanted programmable hardware, so software was equally a part of it. And we were interested in algorithms. We wanted to actually do things. So we picked the focus application. I remember having a conversation with Jerry where I was suggesting chess, and it became clear in about 2 seconds that there were a lot of people working on chess. And I had worked on speech before, so I thought, well, let's do some more speech. Eventually, it did become more speech research than just systems work. And the group had a number of great people who were staff. But as with the other groups, we had great students and visitors. Wanted to focus for a second on a few of the visitors. Here's 3 of us when we had more hair and darker hair, and myself and Hinek Hermansky and Hervé Bourlard. Hervé is here, Hinek is not, unfortunately. And these 2 guys came at different times and really significantly changed what we were doing. And this is a terrible mischaracterization of what we all said in those times, but I'll say it anyway. Hervé says, let's use neural networks to get probabilities for statistical sequence models. That's what I want to do. Hermansky said, well, let's feed nice things into it, maybe something that has something to do with how people hear things. And I said, well, I don't know about that stuff. Let's make something work. So as it turns out, these hybrid systems that put together hidden Markov models, which are these statistical sequence systems with neural nets, are now pretty much what people do. We were kind of out on the edge at the time, as I recall. So we did build hardware. We built this thing called the ring array processor because the topology was a ring. Jim Beck was the key designer. Jim is here somewhere. There you are. Yeah. And he also designed later boards that I'll quickly be dashing through. There were other software people, actually Eric Allman's sitting here, and he helped early on, as did Jeff Bilms. Then later on, we built a chip, and there's a long story to this, and I won't go into it, and Krista hopefully will talk about it. But as Jerry said, Krista was a graduate student at the time, and he really led this design. Then we wanted to actually use it, so Jim designed a board, David Johnson did the software, there are others who helped, but we also put them together in multiples for larger systems, but here's the thing that I think is particularly interesting sort of at 50,000 feet from all of this, is that we actually used the systems we built. This is not typical in academic hardware projects. Typically, you build something, you test it out, you show that it basically functions, and then you write papers. We actually wanted to use them. So we built these boards, we distributed them to friends in Europe and in the US. Not to thousands, we distributed like 20. And then we were able to work together at a level that was really great because we were using the same hardware, the same low-level software, some of the higher-level software, and then people would branch out from there, and then we'd get together and compare what we'd done. So this was long before everybody had GPUs. So before that, the opportunities that we had to work together involved us having very widely varying hardware. So just a few other things about the speech work that we were doing, we did gradually have more and more speech work and less really hard work. Hardware work. It's hard work. So one of we weren't the first, but it was one of the earliest spoken dialogue systems. It was what was called a mixed initiative system, where sometimes the machine would say what was going to happen next, and sometimes the person would. It was the Berkeley Restaurant Project, or BURP, and you'd find out where you're going to go to eat. One of the people who worked on that was Chuck Wooders, who's sitting up there, yeah, and Dan Jarefsky, who I don't think is here today, who's at Stanford. We also did a lot of early work on the task of speech in meetings, which ultimately became a very popular task internationally. We did that for years at ICSI. There's actually a current incarnation, is the Berkeley Startup Re-Meeting, which has group alums Arlo Faria and Adam Jannon. I see Adam there. We did work on measuring speaking rate and analyzing the effects. I think I saw Nikki there worked on that. And multi-stream, actually worked on multi-stream too, didn't you? But we worked on multi-stream stuff for years, also a lot of that in collaboration with partners like Hervé, who's sitting there. So in that first decade, we graduated 10 PhD students out of this group, and 18 more later on at the group. I think 28 PhD students came through the group. Just a few other things we did. Work on who spoke when, on who's speaking. We had some collaborations with a neurosurgeon who got signals directly from the human cortex, and we were trying to learn something about how people understand speech. We learned it a little bit. And studying limitations of modern speech recognition with Jordan Cohen and Stephen Wegman. So around 1998, 1999, there was an opportunity coming up because Jerry, for some reason, didn't want to do it anymore after 10 years. And I thought, well, how hard could this be? It's piece of cake, we were solving speech recognition. How hard could it be to be an institute director? Then I looked at the financials. It turned out to be a little hard. So here was the situation. We'd had this major international funding that you'd heard about, and that was going away. Now we have a continuing relationship with Germany. It's going on to this day, and a lot of it, we have Wolfgang to thank for his efforts on this. But it was a lot more then that was really sustaining the Institute, and some of the other international stuff, like from Italy and Switzerland. So when I first looked at those financials, because the AT&T money, which I'm going to mention in a second, hadn't come in yet, we only had 2 or 3 months left. So there was a lot of scrambling to handle the immediate crisis. But recovery was around the corner. Internet research to the rescue. He looks kind of good in that horse. Okay, so this is the AT&T Center for Internet Research at ICSI, a series, and it was led by Scott, who's the last speaker today. Also, many thanks to Dave Nagel, who was at AT&T at the time, and Hamid Ahmadi, who's right there, who approved this. It perhaps was, I'm saying perhaps was, Scott generally said it was, I believe him, the best internet research group. And later, after the AT&T stuff ended, these folks were fantastic. Actually, a couple of the other ones are Vern, who's speaking later, and Sally, who's sitting over there. They just had amazing success with peer-reviewed federal grants, and so things continued. So during these years, as I was director, there were really 2 primary pillars, the internet research, including security, and the speech and language research, the work in Jerry's group and in mine. Those were just the larger efforts, but there was other great stuff in vision, bioinformatics, and other things. Through that period, it was an increasingly difficult fight for scarce grant funds, but we did okay. We persisted. And that continues now with a more diverse set of things that people do at ICSI, which I'm not really going to talk about. But anyway, Berkeley grad students, faculty partners, international friends, all made it work. And I've thanked a couple people who happen to be here, but there are many more who I really should thank. But in general, great students, postdocs, research staff, the admin staff who've been thanked already, but we no harm thanking them again because they've been fantastic. But I do want to say on top, Maria and Scott, who were my true partners during my director years. There was no way. I mean, I really was an ivory tower researcher, and all of a sudden I had this management position of an institute, not a research group, and it's really quite different. And only with their help could I have done it at all. And then I do want to do a shout out to Maria in particular, who is hiding somewhere. Oh, there she is. For taking on the task of being the executive director over the last couple of years, and she's doing a fantastic job. Okay, that is my talk, but I do want to take a minute just to connect you into the rest of the day. Some past, like you've been hearing, and a bunch of present. First, Mike Luby, who was, as we've said, the early algorithms leader, who took his ideas into industry. Actually changed the order, I think, so Vern is going to be next. And he was originally part of that ICSI group, and he also is the inventor of Bro, which now is morphed into Corelight. He'll talk about these things. Then Nancy Chang, who is now at Google, and we'll talk about the transition to that. And then Kirsta, who we've mentioned, was a Berkeley prof and industry innovator. He's really started an incredible company as well. Then Serge Eagleman, who's the ICSI leader on their growing activity on usable security and privacy, and Vadim Shapiro on cyber manufacturing. And we'll end up with Scott, who is the ICSI chief scientist and visionary and excellent horse rider. And he will finish up with a look into the future. And that's my talk, and now we'll take a 15-minute break.